Moving to day 4, understanding control flow in Python. In any language we learn, whether it's C, C++, Java, everywhere there is a special importance for conditions like if, else, else if. This helps us to define the flow of your code. Similarly, in data engineering, there is a lot of places where you need to define the flow of your the course of your action, the flow of your code. And for that, these Python conditional operators are very important. Let's take some example. If the file arrives in the bucket, we need to trigger few things, correct? So for that, decision needs to be made, and there we use the control flow operators. If revenue is greater than cost, then mark profit as positive. Okay. If column is null, replace it with a default value. If data quality score is less than 90, then send an alert. So these are couple of things. I've just shown you an example where a control flow is an extremely important thing. This is a diagram, a simple diagram I just brought in to show that okay, uh, control flow always have like only two answers, whether it's either true or false, and based on true or false condition, the course of action is decided. In Python we have three main type of keywords to operate the control. One is if, else if, elif, we call it as elif, and then else. Let's take an example here. We have a variable where a value of 12,000 is assigned and a cost is 8,000. So revenue is 12,000, cost is 8,000. If revenue is greater than cost, then the profit is achieved. The answer of this is going to be either true or false. This is a comparison operator that is going to tell whether it's a true or false, and then uh, if will decide whether the control will go inside the condition or outside. Similarly, let's say if we simply change the direction, nothing will be printed. Nothing is printed, right? So if revenue is greater than cost, then the profit is achieved. So this is just one condition that we are trying to use. Now if we want uh, some defaulting to happen, right? Like okay, if revenue is greater than cost, then profit is achieved. We have seen, right? Like if we just simply change the condition, then nothing was printed. But we just want that okay, if there is no profit, then definitely there is a loss. This is a binary state, so we'll use it like that. So similarly, if we have like two, if revenue is greater than cost, then profit is achieved, otherwise there is a loss. So let's run this simply. So if revenue is greater than cost, then profit, else, so the else condition is printed. So this is how the control is then managed. Now there are many places where it's not binary, that okay, if one is true, if profit is achieved, otherwise there is a loss. So if there is a profit, otherwise there is a loss. No, it's not like that. There are certain middle ground conditions also which we need to accommodate. So for example, if revenue is greater than cost, then profit is achieved. But if revenue is equal to cost, then there is a break even point. Okay. Otherwise, there is a default condition called else, which will definitely be true if any of this is not true. Okay. So when there is a conditions are equal, we can simply see that we get break even point as printed as an output of this particular situation. So if revenue is greater, then we'll see a profit is achieved. If cost is greater, then we can simply see the loss is recorded. So that way we can use these conditional statements in three ways. Now combining the conditions with logical operator, right? So we have these conditions. So we have the if statement given, revenue is greater than cost, and, right? So these are logical operators, and will help you to define a very complex set of conditions. In real world scenario, whenever we are doing some operation, we definitely need a lot of complex condition, business condition, which we always call it, right? So whenever we are doing some ETL pipelines and all, the business would give a condition that okay, if certain column has certain values and the values are greater than this and the data is this. So for keeping such complex condition, we definitely have to create a complex web of operators which helps us to define them. And then conditional statements help us to control the flow or control the outcome. Nested if statement, we can even have like a nested if statement. Nested if statement, if country is India and sales is greater than 10,000, then you are a top performer in India. We can nest the conditions like this. You can use and also. Similar things can be achieved with and, but then there are for the readability of code also we do such thing. If we start doing and it creates a complex condition, so sometimes we just try to split it, that if country is India, then do this, then do that, like that. Okay, so it's all how you beautify the code and make it understandable and maintainable. Going to a realistic example, there is one realistic example that is being used. So let's say record count is 1500 and null percentage is 3.5%. It implies if record count is 0, this is a realistic example of a data quality check. Okay, so if record count is 0, it implies that no data is received. If null percentage is greater than 10%, then definitely there is a data quality issue and there are too many nulls. And if there is a default, then data looks good. If nothing is true, then definitely data is good. So let's say we try to change the outcome of this. Record count is 0. If record count is 0, we simply printed no data is received. If record count is if record count is 10,000 but null percentage is, let's say, 23.5, which is definitely greater than 10, then we'll say that data quality issue is there and there are too many nulls. So this statement became true, greater than 10, correct? And if nothing is true, that okay, record count is not 0, so we will not fall into this. Null percentage is also greater than 10, not true. So this is false, this is false. So obviously the control will come here and will print data looks good to load. So this is how in data engineering the conditional statements are very critical. One of the other example is categorizing revenue. So let's say sometime just value is not enough, but it is extremely essential to classify it into certain values. For example, whenever we are doing machine learning, we need certain things that okay, based on the revenue value, we can categorize, we can create different categories. So some of the categories that has been created here are high value customer, medium value customer, and low value customer. Correct. So if revenue is 45,000, and we see that okay, 45,000 is revenue is 45,000 greater than 1 lakh. No, so this is false. So this will not be true. Is 45,000 greater than or equal to 50,000? No, this is also will turn into false. Then will come to else, low value customer, like this. On the similar line, they sometime we might also need something called pass, where we just don't want to do anything. Once the if the condition is true, just don't do anything. Go ahead, like that. So that statement is called pass statement. It is available in many languages, and it is used to pass on to a next set of code. Let's take a simple example. Well, we are trying to what we are trying to do is we are having a sales data for a particular region. US revenue is particular 12,000 and cost is 8,000. Similarly, region EU, so revenue is 6,000 and cost is 7,000. Like that, right? Now, what we just wanted to analyze is based on the revenue and cost whether the region is profitable or not, correct? So that way we just wanted to print that out. Okay, whether US is a profit, EU is a loss or profit, or APEC is a profit or loss. So like that we just wanted to print that out. So we used a loop which we'll definitely understand in the next video, but just for the sake of it, just look at it. So what we have done is we have put a complex set of condition. Okay, if the record is there, I just want in this example I just wanted to show how a dictionary is operated, correct? So that way you understand this. uh, how we are doing it is, if record revenue inside the record, if the revenue is greater than the record cost, then print record and print record, that is region, and region as profitable. So like this. Similarly, we put the condition for profit, break even, and loss, and then we subject this entire sales data set, sales data whatever has arrived, to this set of condition, which is going to help us understand whether that particular region is in profit or loss. So if you simply run this, we could see that revenue of US region is greater than the cost, so US is in profit, whereas European Union revenue is less than the cost and therefore it is in loss. And APAC, where revenue is same as cost, it is in a break-even state. So in data engineering context, control flow arrives ETL decisions, what to ingest, derives ETL decisions, what to ingest, transform, or alert. It is used in data validation, pipeline branching, and conditional transformation. So this is a special areas like data validation. Wherever we wanted to validate the data, we use the if else condition. Whenever we wanted to branch or have a different life cycle for a pipeline, we definitely use the control statement. On the similar lines, whenever we are doing some transformations, business transformation within data pipeline, at that time the control flow understanding is extremely critical because we are trying to implement the business conditions there. So this was all about control flows in Python in the context of data engineering. Thank you for listening into this. In the next video, we are going to understand um, we are going to understand something on loops. Let me just check it out. Yes, we are going to understand something on the loops. So there are two type of loops available in Python. We are going to understand in depth of how Python loops works. Thank you for listening. Thanks.